Hello and welcome to yet another video of Cornerstones of Math. This is more or less an explainer video rather than a straight up problem solving, where I provide a brief review on finding the limit where the variable goes to infinity. The explaining will be at the high school level because that's the main scope of my channel. I have 3 examples, so let us start with the first one. So for the first example, we have this limit. This is infinity over infinity type indeterminate limit, where both numerator and denominator becomes infinitely large when x becomes infinitely large. But some of you might already know how to find this limit. The well-known trick is that the limit converges to the ratio between two leading coefficients, in this case 3 over 2. Some of you might just memorize this as a rule, but more thorough mathematical process is that we divide both numerator and denominator with x cubed, the term with the highest degree, which gives 3 plus 8 over x minus 7 over x squared plus 6 over x cubed divided by 2 minus 5 over x plus 1 over x squared minus 4 over x cubed. And we use the fact that the limits of 1 over x squared, 1 over x cubed, etc. when x goes to infinity are 0. Basically, the rule here is that if the numerator is constant and the denominator tends to infinity, that type of limit always has the value of 0. So it is the determinate limit. But why are the values of these limits definitely determined? Well, if you really want to be mathematically rigorous, then you have to use epsilon-delta method of defining the limit, but that is a college level math and I am not diving too deep here. At the beginner level, such as high school courses, this property is just intuitively understood, so we have 3 and everything else is 0, divided by 2 and everything else is 0, which gives 3 over 2. And of course, during this last step, the following basic properties of limits are applied, whose proofs are also beyond the scope of high school math. So the truth is, we have to gloss over many things even when explaining this simple polynomial divided by polynomial limit. But the basic trick here, such as dividing with the highest degree term, provides an insight to calculate slightly more complicated limits, such as the next one. So now we have square root and cube root functions mixed in this limit. It is still infinity over infinity type limit though. Here, let us also try to use our trick of dividing both numerator and denominator with a term having the highest degree. But we must take these radicals into account here. First, we have x to the power of 4 terms here, but these terms are inside the square roots, so they are essentially x to the power of 4 raised to the power of 1/2, which is x squared terms. Similarly, we have x to the power of 6, but because of this cube root, it is essentially x to the power of 6 to the power of 1/3, so x squared. Therefore, the highest degree we can find here is x squared. So we divide both numerator and denominator with x squared. So we have this. Now, when we plug in these 1 over x squared into radicals, for square roots, the terms becomes 1 over x to the power of 4, because it must be squared. And for this cube root, the term must be cubed, so we have 1 over x to the power of 6. So we have this. And knowing that these terms all tend to 0, we have square root of 2 plus cube root of 8 divided by square root of 9, which is 2 plus square root of 2 divided by 3. For this last limit, we can do the same. If we compare the degrees, we have degree x to the power of 5 over 2 and degree x to the power of 5 over 2 in the denominator. And for this part, because of this cube root, the degree is x to the power of 6 divided by 3, which is 2. Therefore, the highest degree is x to the power of 5 over 2, but this part does not contain x to the power of 5 over 2 term. Therefore, dividing both numerator and denominator with x to the power of 5 over 2, we have, inside the square roots, we have 1 over x to the power of 5, the squared term. But inside the cube root, we have this term cubed, so we have 1 over x to the power of 15 over 2. Therefore, if we simplify, we have this. So these terms go to 0. So we have square root of 2 plus 0 divided by square root of 4, which is square root of 2 over 2. So this part of the expression does not contribute to the limit. And that was all for today's video. Thank you for watching, and I will see you in another video.